right, you guys, so most of the work is done here for you, but there is one of the constructed response question does give you a table of numbers, and it asks you to create a line of best fit for it. So it gives you a place to make a scatter plot. I don't know if it necessarily must be part of the answer. You could do it a couple different ways. What is interesting about if you actually draw the scatter plot is because you're not quite sure, is it a linear relationship? Is it not a linear relationship? So if you want to quickly check that, you can always use your calculator. Remember, we can put our data in the calculator. If you go Stat and then Edit, let me clear out what's in there. You go up to L2. I'm going to clear this out. I'm going to hit Enter. I'm going to go here. I'm going to clear this out. I'm going to hit Enter. And then I'm going to enter in my X values, which is just 1 through 7. And my Y values, so we have 722, 763, 772, 826, 815, 857, and 897. Okay, once it's in the list, we can go ahead to make our scatter plot. You do second plot, it's on, it's scatter plot, it's already using list 1, list 2, it's highlighted on right here. Now, if I do zoom stat, which I think is 9, yep, that'll give me the perfect window for this. Okay, so this makes me wonder if I put in an incorrect value right here. So I'm going to check that, see how this one's way down here. I'm going to check and make sure I entered in my data correctly. Yeah, and see how I put 263 right there? It should be 763. You guys might have already caught that. Okay, so go back to my graph. Okay, there. So this does look linear, okay? Now, what you could do to make your linear relationship, you can either draw this like they did. What they did is they actually plotted these points, drew a line, and what they might have done then is just literally like made a slope triangle and counted up and down, right? I don't think I would have used that one. I would have used this one here. And you can say, I'm going to do that again. Oops. Geez, I can't make a slope triangle. What's going on? I would have used this one here. Because in yellow, I'll show you, this is an exact like point, and this is an exact point. So I can literally count up or down, right? From my distance on my Y from 2 to 6, okay, is 4. To get from 2 to 6, I go up 4. This is obviously positive. And to get from here to here is from 750 is 100. Okay, so if I had chosen these two points, my slope would have been 100 over 4 or 25. Okay, you can see that down here, they obviously did something else and they got 27, but as long as somebody's sending a remind, you guys, you show me how you did it. I mean, these are all going to be estimates. It estimates anyway, okay? But I can show you how they might have done it on this, on the calculator. Once you have, okay. Give Abdi a hard time about this. Once you have on your calculator your plot, you can go back to Stat, arrow over to Calc. Then this is linear, so I'm going to go for linear regression. Enter. And then this is an old calculator that we're using to view. Don't do that. I just wanted to get that out of the way. I want to show you what to do if you have this. This is an old one. So what we need to do is we need to put in our list. So I do second, I put my X in L1, comma, I put my Y's in L2, right? And then I think I can store it if I do comma again, vars, Y vars. You do not have to do this. I just wanted to see if I could enter. I want to put it in Y1 and see if that works, okay? Then it gives me, so look, they must have used the calculator to find their line of best fit too. I don't know, I don't think I can write on this, but if you look at A is 27, that's the slope, y equals ax plus b, it says A is 27. So that corresponds down here, right? And then the y-intercept, 699.42. This is exactly what they did. And that's how they got this equation here. You didn't have to do that. You could have done what I did at the top where I got 25, and then I could look right here. Obviously, I can see I would have said that 700. If I had drawn it just like this, I would have said my line is approximately 25x plus 700. Okay, but let's go back to our calculator. Let's see if it put it in the y equals like I asked, and it did. Okay, so see how it automatically populated my y equals. And actually, you guys, let's put the one I came up with on the graph. Let's do 25x plus 700 instead and see the differences between these two. I'm sure the calculator will look better. It's going to graph the calculator one first and then mine. So there's the calculator straight line. Well, and then there's the one I did by hand. And look, they came up pretty close. So whichever way you want to do that. The test will also ask you a couple of other questions. It asks, to interpret the slope. Okay, so we want to interpret the slope. Hopefully you know how to find the slope. If we use the one that they came up with here, that the calculator came up with, 27, okay, that's the rise over the run, and it's y over x, right? So it's 27 over 1, really. And 27, what does the y stand for? In this case, the y stands for the first 7 football games. The people, y is the people who attended each. So the amount of people that attended the football game, and x is the number of games, first game, second game, third game, fourth game. Okay. So what does this mean? It means 27 people or more people attended for each game. Okay, for every game, 27 more people attended. So the first game, if there was 700 people, then the second game there was 727. So 27 more people attended each game. I'm assuming that they're doing pretty well. Like the Broncos right now, I'm pretty sure it'd be a negative slope. For every game we lose, 200 more people do not attend the game. So maybe if they're winning, 27 more people will now go to the game. Now, can this go up forever? No, it can't, because there's only so many seats in the stadium, right? So there's going to be an end where it can't go anymore. So that's exactly what the test is asking too. It's asking for a good domain and range for the context of the problem. So in this problem, our domain, you know what this problem wants? Our domain wants all positive values, right? We can't have a negative amount of games, right? And domain is the x values, range is the y values. So domain, let's do domain in yellow, and we'll do range, let's say is, our y's are the blues. So the number of games is going to be our domain, because that is, well, so let's do this. We'll write our domain in yellow up here, and we'll do our range in blue here. So our domain, our x value is between greater than or equal to 1 game, right? And less than or equal to, it says the first 7 football games of the season. I don't know how many games are in a whole season of football, but let's say 16. I'm sure you guys will tell me if I'm right or not. Less than or 16, because we can go up to 16 games, right? We have created an equation that does not only work for the first 7 games, but that we can use to predict how many are going to come every day, every game that season, right? So our X value, our domain, is between 1 and 16 games, right? And our range is the number of people. So our range, if you start at 700, was the amount, or 699, let's say 699 people. So we're going to be greater than or equal to, y is going to be greater than or equal to 699. That's our lower value. And less than or equal to, if there's 16 games, we've got to put that in our equation, right? So where's my calculator? And I'm just going to go to the table, and it'll have everything filled out. So I'll just go down to 16 games. Okay, so the equation the calculator came up with said it'll go up to 1,131 people. The equation I came up with said 1,100 people, but we're using the calculator equation, so I'm going to not do part of a person. I'm going to say 1,131 people. So in the context of the problem, you can use this domain and this range. An easier way to do it is that you're never going to have any negative values. So if you wanted to say the domain and range would be all real, no, I'm going to leave it like this, because you're not going to have the stadium has a certain number of seats. So let's just stick with this. After 16 games, these are the amount of people that's the most people that would show up for 16 games. Or we could technically change our range to be, instead of just being what we get out of our equation, you could end it with the number of seats. It can only go up to however many seats are in this stadium. So if you wanted a more general range, and you guys, as long as you explain what the range means that you wrote down and it matches what you came up with, I'm okay with that. We could say our range could be 0 people, right? All the way up to maybe there's 75,000 seats at the stadium. I don't know. Isn't that how many are at Mile High? Okay, so this would be exactly from our problem here. And this one would be a more general, our stadium seats from 0 to 75,000 people. Either way you write your range, as long as you explain it to me, that's cool. Oh, and then the last question is just doing some solving, which we already did, so I'm sure you can do that. If so, on the 8th game, how many people will show up, or vice versa? Okay, so again, good luck with this studying, and I will see you tomorrow.